Good morning, class. How are you? Yes, I am fine. So we are now in the volume and surface area. Many things we have revised, many things we have learned in the classrooms also. Various questions you have raised, we have solved together. Okay, so that is the advantage of online classes right now in this pandemic situations, and you are all taking the advantage. That is very good thing also. Okay, you are coming regularly in the classroom, so that now in this chapter volume surface area everything you have understood. Okay, if something is still remaining, so these videos are there, so you can take help of these videos and this will become very much helpful for you. Okay, so what we have read in this one last time, we are just going to revise this all. We have read the definition of mensuration. We are now knowing the what is mensuration. We are knowing what is the difference between 2D and 3D shapes. Then we are knowing what is the lateral surface area, which is area does not include the base area, that is called the lateral surface area, or that surface, that plane which is connected to base is called lateral surface area. Okay, total surface area is the surface area of entire object. Okay, volume, the space, the three-dimensional space is called volume only. Okay, we are knowing these things. Then we have learned about these shapes also. Sphere we have learned about that cube. We have read about this cuboid, cone, cylinder, hemisphere. See, all these are there in the previous video, so you can just go through those videos and you can just see this. Okay, now the question is that when the shapes are combined, that type of questions can also come there. Suppose one thing I would like to explain here, that in this question, read here. Okay, read this question here. Question is saying that a hemispherical depression is cut out from one face of a cubical wooden block, means from this block this part has been removed. Then what is the surface area of the remaining solid? So don't forget these things. Okay, so in that, the surface area is that will in this calculating surface area here, we will not calculate this much part, the area of this circle, because this has been removed, and we have removed this one there, this hemispherical part. So that much part is still remaining there. So you have removed this part, but this part is there in that solid, so that will be also included. We have read this in the previous chapter. Then we will read about that combination of shapes. Okay, this is the combination of cone plus hemisphere. This part is cone here, see here, this part is the cone, this part is the hemisphere. Okay, so we have to find the volume of this thing. That means we have to find the volume of hemisphere plus we have to find the volume of cone. So in this way we'll calculate this, and I have made one question video there, we'd like to share with you there, and that will be really helpful for you. Okay, wait a minute. Here is that video. Okay, here is this video here. Okay, so here is this video, and here I'll explain first what does it saying here. It is saying that it's a combination of figure. It is saying that a vessel is in the form of hemispherical bowl mounted by a hollow cylinder. We have to find all these things, are height is given and these are given there. We have to find the capacity of the vessel, and we have to find the inner surface area of the vessel. So we'll draw the figure. From that figure it will become more explainable there. See here, that is the figure we are just going to draw for this. Okay, they are saying that a vessel in the form of hemisphere. So now I'm just going to erase this and I'll draw this figure, a small figure I am drawing here just now, so that I can remember what the question was saying there. So in this question here, now I'll erase the board and everything is given. Okay, just remember the information and you will surely solve this. Okay, The question is saying that I will make this figure large one so that we can understand it nicely. On this hemisphere, a cylinder is mounted. That means cylinder will be on the top. Which is mounted, which shape is mounted will go on the top there. Okay. Now, radius is given. Okay. The total height of the vessel is given 30. Okay. And this radius is given 7 centimeter. Okay. That means height of the hemispherical part is also 7 centimeter, because I have explained that why it is so. Now, this vessel will find the height of the cylindrical part also, because we have to find the volume. For that we need the height of the cylindrical part also. So from this total part, if the hemispherical part is subtracted, the height of the hemispherical part is subtracted, we will get the height of the cylindrical part also, correct? So here first of all we'll find the radius. Radius of both cylinder and hemispherical is same only. So that means in case of hemisphere, radius is equal to height, so that is equal to 7 centimeter. Okay, the height of the hemispherical part is 7 centimeter. No need to explain that again. Now, why we have found this? We have found this to find the height of the cylindrical part. Okay, so what is the height of cylindrical part? So that is equal to, from this total, that is 13 minus hemispherical part, that is 7, so that is 6 centimeter. Now this height is 6 centimeter. Radius is already same, common for both hemisphere, and in this type of cases radius remain the same only. Now we are in a position to find the volume of the vessel there. Very good. Now we are just going to find the volume of the vessel. Okay, what is that? So the volume of the vessel is volume of cylindrical part plus volume of internal capacity is volume only, volume of hemispherical part. Okay, okay. So now volume cylinder is pi r square h. Okay, pi radius is given 7. Okay, pi r square h, height is given 6 here. So that height of cylinder is represented by greater larger h, capital H, and that height of this one hemisphere we don't need, only because we need pi r cube. So now pi r square is common only because it is common, so it is h plus 2 by 3 r. Now put the values there. 22 by 7, radius is 7 into 7. Inside it will be h is equal to height of cylinder, that is equal to 6 plus 2 by 3, radius is 7 only. Okay, now that is the centimeter cube. This is the volume there. Now when this all will be calculated here, 7 cancel, so it's 154, and this is equal to 32 by 3. Okay, so when this all will be multiplied, so the total volume of this will come, I have calculated earlier, that will become 161,642 centimeter cube approx. It can be decimals place difference there, no problem. Sorry. Now what we have to find? We have to find the surface area of this vessel. Inner surface area we need to find there. Okay, so let us start that. So we have to find the inner curved surface area, that is the curved surface area of cylinder, plus that is the curved surface area of the hemispherical part, correct? Plus hemispherical part. So how much this will come? You are knowing this very well, at how much this will come. So here that is equal to 2 pi rh plus this is 2 pi r square. 2 pi r is common here, okay, that 2 pi r is common because radius is common for both the shapes. So that is 2 pi r will only come outside, inside will be h plus r, and all datas we are having there. So it's 2 into 22 by 7 into radius is given 7, height is given 6, radius is given 7, 7 cancels, 44 into 13, okay, so that is equal to 572 centimeter square only. So that is equal to 572 centimeter square. And this is how we will find the inner curved surface area of this vessel, which is a combined shape, combination of hemisphere plus cylinder. So this is how we used to find these all things. Next class we'll learn some new topics. Till then, all of you take care, keep reading, keep revising, keep learning. Thank you class, thank you very much.